Good morning. I am Kavitha Rani PR, Assistant Professor of Chemistry. Today I am going to take about a topic, free radical. First free radical is identified as triphenyl methyl free radical. Today we are going to learn about the geometry of free radicals, characteristics of free radicals, classification of free radicals and stability of free radicals, and some reactions are take place by the presence of free radicals. And for introduction about the free radicals are, first identified free radical is triphenyl methyl free radical. Free radical is the term, the molecular species which can contain unpaired electrons. Unpaired electrons, so it is a paramagnetic in nature and it exists independently. The paramagnetic, the unpaired electrons gives the paramagnetic nature and it possesses a permanent dipole moment, small amount of permanent dipole moment. The free radical is formed by homolytic cleavage. For example, homolytic cleavage of chlorine atom gives the free radicals. The covalent bond is homolytically cleaved to gives free radicals. Free radicals are formed different ways. First one, TPD, thermal decomposition, photochemical decomposition and thermal cleavage, photochemical cleavage and decomposition. These are TPD, thermal cleavage, photochemical cleavage and decomposition. In thermal cleavage, the free radical is formed by high amount of temperature. High temperature is given to a compound. For example, azo compound is formed by the thermal decomposition. And 20 to 40 kilocalories of energy is required to cleave a bond, and gaseous form of the compound is break into liquid form. The azo compound is formed by thermal cleavage. And another formation of free radical is photochemical cleavage. Photochemical cleavage is the cleavage covalent bond is cleave in homolytically cleave in presence of a light in a specified wavelength is given to a compound to give a cleavage to form a free radical. Chlorine is formed by the chlorine free radical is formed by this method, photochemical cleavage. And another one is decomposition. The phenyl radicals, phenyl radical is formed by a decomposition method. Free radicals in body. Free radicals are unstable molecules that can damage the cells, DNA, other macromolecules in a body. When oxygen, during the metabolism, oxygen molecule split into a single oxygen atom. Oxygen atom have unpaired electron. So the unpaired electron in presence of oxygen atom have a tendency to form a bond with the other molecules or other atoms. So this happen in process continuously happen to form a oxidative stress. This oxidative stress is an imbalance between the free radical and the antibody in our antioxidant in our body. And the presence of free radical in a body causes many diseases. That is causes illness, aging and increase the risk of cancer and diabetics, arthrosclerosis, Parkinson's disease, Alzheimer's, neurodegenerative disease like Parkinson's disease, Alzheimer's disease are due to the free radical creating in a body. And heart diseases and high blood pressure, these are formed by the presence of free radical is in a body. And how the free radicals can reduce in our body, that is the presence of antioxidant. Antioxidant is a substance that protects the cells from damage caused by the free radicals. Free radicals and antioxidant, two different types of molecules or chemical compound that play role in how your body works. Your body needs both types of function properly, that is free radical and antioxidant. Antioxidants are scavenge the free radical, and the unpaired electron present the free radical that is scavenged by the antioxidants. So, the oxidative stress can reduce the presence of antioxidants. The natural antioxidant, that is antioxidants, can be taken from our body, food. The body can scavenge the free radicals through the antioxidants. From the diet we can obtain from the diet. And characteristics of free radicals. There are free radicals are neutral species, cation species. The free radicals are total number of valence electron is 7, and free radicals is maybe trigonal in shape and planar shape. Due to the incomplete octet, free radicals are highly unstable, and because of strong tendency of the carbon atom carrying the odd electron to acquire one more electron to complete its octet. Free radicals are very short-lived and reactive species. There are two types of free radicals: short-lived free radicals and long-lived free radicals. Comparing the short-lived and long-lived free radicals, short-lived free radicals are highly reactive. Due to the presence of odd electron in free radicals, they are paramagnetic in nature, and free radicals usually obtained in the presence of heat, light, electricity, in presence of peroxides also. Three different type of free radicals, that is neutral free radical, cation free radical, and anion free radical. The most free radicals are quite unstable, very reactive, because due to the presence of unpaired electron. Geometry of the free radical. Geometry of a free radical, that is alkyl halide, have sp2 hybridized free radical and sp3 hybridized free radical. sp2 hybridized free radicals are planar in shape, and sp3 hybridized free radicals are pyramidal in structure. Carbon atom have atomic number 6 and one unpaired electron, that is in the valence is 7 electrons, that is the unpaired electron, unpaired and hybridized contain odd electron, that gives a planar structure, and sp2 hybridized. Classification of free radicals. Free radicals are three types: primary free radicals, secondary free radicals, and tertiary free radicals. Primary free radicals, one carbon attached to a carbon atom which contain odd electron, that is free radical carbon attached to one carbon atom, that is primary, and free radical carbon, that is the carbon atom having odd electron is attached to another two carbon atoms, it is a secondary free radical. And carbon atom having the odd electron which is connected to three carbon atoms, it is a tertiary free radical. The stability of free radical is tertiary is more stable than secondary and primary. And stability of free radical is influenced by various factors, that is inductive effect, hybridization, conjugation, and cathodirective effect. Inductive effect is the inducing an inductive effect to a free radical. Presence of alkyl group, that is electron withdrawing group electron releasing group is attached to a carbon containing odd electron, that is the free radical. The number of alkyl group increases, the free radical stability increases. The reason behind this is alkyl group is electron donating and inductive effect which reduce the free radical's electron deficit. So methyl free radical is less stable and tertiary free radical is most stable. The primary and secondary free radicals are in between that, because the alkyl group connected to the free radical, number of alkyl groups increases, that increases the inductive effect and that reduce the radical's electron deficit. So tertiary free radical is more stable than secondary and primary. Comparing the primary and methyl free radical is less stable. Another property influencing the free radical stability, that is conjugated system. It is a system connected to p orbitals with a delocalized electrons in a compound with alternating single and multiple bond, which in general way lower the overall energy of the molecule and increase the stability. P orbitals with a delocalized electron in a compound, that is alternative single and double bond, which lower the overall energy of the molecule, and in this way it increase the stability of the free radicals. For example, allyl free radicals, that is it increase the stability comparing to the other free radicals, that is vinyl. Allyl free radicals have alternate double and single bond. So it is conjugated system gives the stability to the free radicals. And another conjugated system, that is benzylic radical. The free radicals have alternate double and single bond. The pi electrons are localized with double and single bond. So the overall energy of the molecule reduce the increase the stability of the free radical. Allyl and benzylic free radicals are stable due to the conjugation system. Another one is hybridization. Hybridization also give an influence in the free radical stability. The geometry of free radical considered between sp2 and sp3 hybridization, and energy required to invert pyramidal system is very small. So it gives a stability to the free radical. And another one is cathode-active effect. The cathode-active effect is the effect on the stability of a carbon-centered radical that is determined by the combined action of a electron withdrawing and electron donating substituent is attached to the carbon atom. Both are attached to a free radical system. It gives a energy to the overall molecule and gives the stability of the free radical. That is called the cathode-active effect. Cathode-active effect is the electron withdrawing group and electron donating group attached to the same free radical carbon atom. That gives the stability by reducing the overall energy and gives the stability to the free radicals. And the summary of the free radical is stability, that is adjacent to the electron withdrawing group, that is less stable, and electron releasing group is attached to a free radical, it is more stable, because the electron negative atom is attached to a group. Electronegative group is attached to a carbon containing odd electron, that is the free radical. Electron with negative atom have a tendency to withdraw electrons from the free radical, so that is less stable, whereas electron donating group is attaching to a carbon containing odd electron, that is the free radical. It gives more energy to the free radical, and the electron deficit is reduced by the presence of electron donating atom donating group attached to the free radicals. So comparing to electron withdrawing group and electron releasing group, releasing group attached to free radical is more stable. And another one for stability affecting factor is S character. That is S character is least stable. That is, for example, in alkane system sp hybridized, that is less stable, whereas alkyl group attached, that is in sp3 hybridization, one s and 3 p orbitals are involved. One s and in sp3 hybridized system, one s orbital and 3 p orbitals are involved. So the 25% of S character in alkyl group. So the S character influence the free radical system. How it affect means S character is less, it is more stable. Increase the S character, the stability will be reduced. For example, the alkenyl radical is least stable and alkane radical is most stable. And another affecting factor is stability affecting factor is electronegativity of the atom. Free radical attached to a highly electronegative atom, that is less stable, and electronegativity decreases it become more stable. For example, in the halogen family, fluorine atom is less stable and iodine atom is more stable. Iodine atom attached to a free radical that is more stable than, whereas the fluorine atom attached to a free. Increasing the electronegativity of an atom bearing free radical means that partially filled orbital will feel a greater effective nuclear charge, which result the higher electron affinity. Free radicals on these atoms are more likely act as an oxidant and removing electrons from atoms to lower ionization and energy and thereby become negative ions. These are the factors affecting the stability of the free radical. And the free radicals involved reactions. Wood's reactions are carried out in presence of free radicals, and Kolb's reactions carried out in presence of free radicals, and the Markovnikov's additions and chain propagation reaction, chain initiation reaction. These are influenced by the free radicals. Thank you.